share my screen. All right, welcome back. Let's continue from where we left. Just looking from a timing standpoint, I think we will do a bit, brush through some other things rather than spending so much time so that we are able to cover at least the gist of each domain, right? So I will move from the different, the benefits of the different cloud, I think we all understand, but for the public and private, community cloud is something which you don't, at least in my day to day, I haven't come across much, but it's not as popular as public or private cloud that we talk about, but it's very much similar to public cloud. um, it's basically when a group of companies or individuals come together and create a closed group cloud, right? So for it mostly works for things like universities or financial institutions coming together, or an industry bodies coming together, or members of an industry body coming together and creating such cloud, which is basically where the resources of the cloud are only accessible by the members of that group. And you can have this infrastructure again provisioned by a public cloud like AWS and Google, but at the same time, the membership is restricted to a closed group of individuals. That's the characteristic of a community cloud as such. Um, this basically allows you more collaboration. I think mostly it's in the space where you need to share data and collaborate with a closed group of individuals. That's what I said is essentially one of the key business requirement why somebody would go and prefer for a community cloud as such. Hybrid cloud is really the reality where I don't think, I would say majority of the companies or organizations would actually be on a hybrid cloud format where um, you are able to get the best of both worlds. So if you are already not just the best of both worlds, but if you're already traditionally have been on-prem and you're trying to move to cloud, you'll always be at a point where something is still left on-prem and some things are in public cloud. That's what the hybrid model is, because not everything can be 100% always be in cloud for multiple reasons, information security being one of them. um, uh, this is also a very good trade-off of using cloud while still trying to be on-prem for some of your core critical data that you cannot afford to put on a shared infrastructure. So the other aspect is cloud bursting. Cloud bursting is essentially you may use cloud, you may use on-prem as your primary um, um, infrastructure, and then in cases of an expanded need, let's say in a busy season or in case of uh, um, a spike in your demand for whatever reason, the setup is in a way that the extra capacity is fetched from the cloud. So it's only used um, in those situations where your existing on-prem capacity goes beyond limits, and then the extra load is then shared with the cloud that you have subscribed to. That's called cloud bursting in a nutshell. That is possible with hybrid cloud. Um, so moving from those fundamentals that we talked about, which is more about the aspects of the different types of cloud deployments, now we move to the next set of fundamentals, which is about different roles that are there in the cloud setup. So you have NIST defines it in a certain way. It talks about cloud provider, it talks about a broker, customer, auditor, and carrier. And then ISO uh, defines it in these three categories of cloud service customer, service provider, and cloud service partner. Now, if you the NIST 292, which was there earlier, is basically sets up the cloud reference architecture, and the reference architecture is basically the common framework against which any cloud service provider can fit into. You can basically um, uh, dissect that particular cloud service provider against that reference architecture that that either NIST or ISO provides. But the way you dissect it is, okay, who's the cloud provider here, who's the cloud broker, who's the customer, what activities each of these different roles do. That's the referent architecture that is defined by NIST in that fashion. I think most of the definitions are self-explanatory except the broker. Broker is essentially what a broker is typically in our day-to-day life. He is the um, uh, that role is that particular entity that finds solutions to cloud computing needs. It's a value-added service. It could be either a reseller or a system integrator who then aggregates different cloud services that are available in the market and brings the best possible choice in front of the customer. So that's the broker. I just wanted to make sure that that definition is understood. Cloud carrier is basically your network or ISP provider. What connects you to the cloud is the cloud carrier. In the ISO world, the cloud service provider is essentially something that may be um, unique to understand. Cloud service provider is typically those entities that work with the backend cloud service provider. So if you've seen companies that provide a service to the end customers, but they use at the backend, an AWS or a Google or Azure to make it happen. Like they co-brand themselves. It also helps the cloud service partner to reach to customers where they don't have their own setup, they don't have their own infrastructure. So it enables the cloud service partner to actually go to those remote locations or those geographies or markets where they cannot afford to set up their own IT, but they work at the back end with a cloud service provider, and typically they co-brand. So like you say, a service XYZ powered by AWS at the back end. This is the NIST reference model or reference architecture. You see the different roles that the NIST we spoke about and all the things, what happens under each role. I think it's good to go through the 500 292 NIST special publication to understand more about it. It will be helpful from a CCSP standpoint. Now we come to the key cloud computing characteristics. It's interesting here because, as I was saying in the beginning, when you look at the definition, each word in the definition had its own dedicated explain. I mean, should be understood in detail because what separates cloud from a managed service provider, what separates cloud from a virtualization concept is what characterizes cloud, and these are some of the things that does. So both ISO and NIST does it more or less the same way. So we'll talk about each of them in a bit more detail. Only thing that you would see the difference between ISO and NIST is multi-tenancy is not a characteristic that that is called out by NIST, because multi-tenancy, as per NIST, is treated more as a source of risk in cloud rather than a characteristic. So because of multi-tenancy, all the issues or concerns or potential or perceived risks come into play. So we'll talk more about each of them. Just one thing also to when we talk about multi-tenancy, to be clear, is multi-tenancy is not just something that you would associate in a public cloud format. It's also in a private cloud setup as well. If you have your own dedicated data center with a private cloud setup, you still use multi-tenancy because you still virtualize your resources, and you still have an extent or a degree of risk that a tenant there could be one department within your organization could have unauthorized access to another department's information if the controls for the multi-tenancy fail or the hypervisor fails there. So it's common to all cloud formats, multi-tenancy. So here are the things we will cover quickly. Broad network access, some of the controls that also we need to probably discuss, and it gets discussed in CCSP, is the use of secure transmission protocols. At the end of the day, if you have access to cloud over network, everybody else also has access to the same. But you need to ensure that certain controls are in place so that the risk is mitigated, which includes secure transmission protocols and also use of identity and access mechanisms, multi-factor authentication, etc., so that only the right person has access to the resources. Measured service, we talked about it, self-explanatory. It's a key characteristic because if you're not able to measure, you will not be able to pay as you go. So then it again falls back to the typical always available infrastructure and you pay whether you use it or not. That's not a characteristic for cloud. So there should be a mechanism to measure the services consumed and then be able to charge those back to the tenants. Um, On-demand self-service, we talked about it. Some of the things to which will get covered here would include how it leads to and shadow IT, how it leads to what we call as a VM sprawl, which essentially means that the ease at which individuals or tenants or users of the cloud can demand or can launch these services by the click of a button. If you don't have enough governance and management control on it, you would end up having a lot of shadow IT. People will be creating VMs on the go, putting data out there at unsecured places um, in unsecured ways. There'll be financial overspend because you're using so much resources from the cloud, and you will not have other controls like let's say SOC monitoring on all the VMs that are being launched all over the place, et cetera, et cetera. So it's more of a governance and management control that needs to be in place while you practice the benefits of on-demand self-service. But those are some of the things that CCSP will cover in more detail as you go through it. Um, Rapid elasticity. Elasticity is also very much related. You have the same risk that I just spoke about, um, because rapid elasticity means that uh, um, you would be able to uh, provision almost unlimited number of resources or computing power as much as you need. But again, you need to have some limits in place. You need to have controls for management from a management perspective of how you contain um, the amount of workload or amount of computing resources that your organization is using through cloud, using the on-demand and rapid elasticity features of the cloud. Resource pooling is the core of cloud computing, without which cloud will not exist. One of the things that gets discussed within resource pooling is also how those shared resources are then orchestrated in an automated fashion to meet different demands, provisioning, deprovisioning of those resources, configuring those resources, making it available to the tenants on demand. Concept of orchestration comes into play. Resource pooling also leads to the risk of multi-tenancy because at the end, everybody is using the same resource pool. Hypervisor compromise is key control or key risk that rather put all tenants at risk. Some of the controls that gets discussed here are more about encryption, because you cannot really rely on who has access to your data at the shared resource level. Cryptographic erasure, which is a concept about how you are ensured about um, the deletion of data in the cloud, because at the end of the day, the data resides on hard or the hardware on which the data resides is in a shared resource pool. So even if you say delete, which basically means you give back that resource into the pool, you need to make sure before that happens, the data that is there is not usable, even if it is accessible, which means one, it is encrypted, and two, it is encrypted to a point that it cannot be decrypted again. So cryptographic erasure is the concept where you encrypt the data with an encryption key, and then you encrypt that encryption key with another encryption key, and you delete both the keys or destroy both the keys. So basically, there's no way to decrypt the information that exists on those devices or hardware or memory, um, because it's always encrypted and cannot be decrypted back. So only thing you can do is overwrite with fresh data that the new tenant uses. Okay, so moving on from there, there is building block technology. So these are what make cloud computing possible. Virtualization, it's not unique to cloud, um, but again, it's also, although it's the necessity for cloud to exist or to work, it's also the key area where a lot of security and compliance concerns come in, because as I said earlier, you can move your data. I mean, the cloud service provider can actually leverage the excess capacity by moving the data and services across multiple geographies. That's one issue from a data localization standpoint, for example. And the hypervisor security, the virtualization layer itself is a single um, point of failure in a sense, where if it fails, basically that literally um, um, creates a flat structure for all the tenants that exist on top of that virtualization layer. Um, so some of the technologies also that gets discussed in this domain are about different types of storage. There is storage area network, network attached storage. Um, again, it goes and stresses on the fact that how the data disposal is a concern in this in the storage in cloud. I spoke about it just before in the previous slide, how crypto shredding is the other word for cryptographic erasure is used when you try to dispose data in cloud. Networking is a key characteristic of cloud and a building block technology. Encryption and secure transport is one of the controls that is paramount within the networking technologies that gets discussed. We talk about databases. I mean, there are a bunch of different types of databases that can be used in cloud, which would not have been possible in traditional setups. Um, and orchestration, which I talked about as well. So it's more than just automation. It's basically with a click of a button, what all happens behind the scene to provision, deprovision, configure things as per the requirement of the tenant. That's what the orchestration is all about. So these are five um, technologies that really would be considered as the building block technologies for the cloud. I mean, there are a lot more here, which I won't get into too much of detail right now, because we probably covered and touched upon these one way or the other. You see these risks coming from virtualization. We spoke about many of them. Um, what type of controls you can put in place, we touched upon them. Uh, I mean, this is essentially, oh, okay. So we can get into a bit more into the um, probably the reference architecture itself. Um, the reference architecture, the need for a reference architecture is essentially to allow for interoperability. Um, it allows, as I said, to map the cloud computing activities and their capabilities across different cloud providers or different vendors into one single framework. So what you see here is what the NIST 500-292 talks about from a reference architecture standpoint, and their reference architecture is around the roles that the cloud computing contains. So those roles we covered as well in the previous slide. But I don't think there would be a lot that I would cover at this point on the reference architecture, because some of that could be repeat. It just gets into more detail of um, the different risks and different controls that come into question as you discuss the activities that those roles play. But there are some shared considerations. When I say shared considerations, it basically means that um, no matter um, which cloud environment or which vendor you're using, these considerations will always apply when you're using cloud. Um, and it's more from an architecting concept, from an architecture standpoint, you need to be mindful of some of these things when you're moving to cloud. It basically is interoperability, which means that Can you work with the data which is stored across multiple cloud providers? Portability, can you move from one cloud service provider to another? Both of that is to do to avoid yourself from getting into a vendor lock-in situation. Uh, Reversibility, again, the third characteristic which allows you to avoid vendor lock-in is what is the measure of this extent that the services can move between different environments. So when you're going to cloud in a multi-cloud setup or a single cloud setup, and you're thinking of architecting that, these are some of the considerations that you see on the slide that that is spoken about in more detail in this domain. That helps you make sure that your cloud architecture is not just secure and safe, but it is also resilient and aligned with the business strategy for years to come. We also talk about in this module some of the newer technologies and how it impacts machine learning, AI. I mean, nowadays everybody's understanding how the GPTs and the chat GPTs and large language models are are the buzz these days, but then how cloud at the back end is actually enabling with unlimited or near unlimited computing power and access to resources, how these new technologies are so um, um, I would say are leveraging cloud at the back end. So blockchain is another example, how it provides a storage method um, uh, using a distributed open ledger model. Internet of Things, again, cloud is at the back end when it comes to Internet of Things, of how it helps in storing, aggregating, and also mining data from different IoT devices. In cloud, we talk a lot about containers, another approach to virtualization, and how it um, um, how it is core to some of the aspects of cloud like microservices, serverless setups, etc. So I won't go again into all of that because it would take a lot of time for us to just cover this domain today. But I'm just giving you an overview of how some of the things in this domain really goes through a lot of the different fundamental aspects of cloud architecture, cloud characteristics, and cloud service models. Um, okay, I think we will try and run through the remaining slides a bit quickly because I do want to have some time where we can actually go through some questions and maybe it will be much more interesting to do some questions and discuss those rather than going through the slides because as I said, this is not for us to go through the content in detail. It's not a study session. It's just to give you an understanding of what a flavor of what gets covered in these domains in the CCSP. So I hope you got that understanding largely. For domain one, it's basically fundamental concepts of cloud computing. What is cloud computing? How you define it? How is it different from other related technologies? The different service models, deployment models, how you define a reference architecture, what are the different roles that exist within the cloud. And we also talked about, while we were talking about all this, what type of risks come into play with those characteristics and those technologies. So I think that gives an understanding. I'm happy to, if there are still any questions yet. If not, in the interest of time, I would actually try to jump more into the Q&A because I've set up a poll where we can actually do some questions on this domain as well. So just give me a second. Let me just quickly check one thing. Okay. So let me skip some of these topics, which I think just does nothing but dive further. But let's do this knowledge check. So again, I'm sharing the QR and the link to this particular poll. If you all can log in, we can then try to go through some questions here. All right, so let me try to go back to my activities. I'm sorry, I'm doing all this live. Okay. Um, so I hope people are able to log in to the poll. Do it as well. And I think you can see the poll, right? So you should have this question in front of you. And let me know what you all think about it, because I did cover it while we were speaking. Yeah, so I think that's correct. Majority, rather all of us have answered this, right? So it's a platform as a service, because if you look at the beginning statement, Alice is the CEO for a software company. So think about it. It's a software company. They build software. If they build software, their main focus and priority should be just focused on building software. They don't want to manage the infrastructure, and therefore PaaS is the only option. They don't want SaaS because they build software. There is nothing in the definition of CCSP as backup as a service, although you can debate about it, but it doesn't matter. And then there's an infrastructure as a service, which they don't want to worry about. So that's the way you would approach this. Platform as a service is the right answer to this. Right. Moving on to the next one. I hope you can see this and answer the question here. Are you able to see the next question? Yep, good. I can see responses coming. So the second question, the answer to that is I mean, everybody's saying SLA. Um, yeah, so I think when you look at this question, I will block the question now. And the answer to it is essentially multi-tenancy. Because when we went through it, if you realize multi-tenancy is the genesis of many risks that the cloud poses, right? So she's not concerned about SLAs. SLA would be a way or a means to actually to alleviate those concerns, right? The concerns are coming from multi-tenancy. So very important to read the question slowly and understand why a word has been placed in the question, because sometimes that's what flips it completely. So I hope this is helping. Moving on to the next question. All right. I hope you can answer the third one. That's correct. Yeah, so turnstile is not the right choice here, because um, because that is a physical control, and that's something that won't be uh, uh, a concern, because um, it's something that is taken care of by the service provider. What's more important, how you're monitoring your data egress, encryption, digital watermarking. Those are the things that you would be concerned about moving into cloud. Those are the new things that takes more prominence as you move into cloud. All right, so next question: which of the following is not a method for creating logical segmentation in a cloud data center? Is it VLANs, NAT, bridging, or hubs? So the answer is correct, hubs. Those concepts of hubs and NATs and VLANs that apply in traditional environments still applies in cloud data center, although it's in a virtual setup. Hubs essentially broadcast the information. They don't really work in a logical, uh, is not a method for logical segmentation, while others are, right? So it's more of a networking concept, but important to understand. Okay, so the next one. Oh, I think I'm not progressing on the screen share, but let me do that. Uh, all right, so next one is here. So according to IC, the lack of physical endpoints as individual network components in the cloud environment creates what kind of threat or concern? Are you able to answer this one? I'm not seeing any answers yet. Okay. Good. So the answer is correct. Whoever have answered so far, the lack of defined endpoints makes it difficult to uniformly define, manage, and protect. It makes it difficult. It doesn't make it impossible, as the second choice says. Um, and all the other choices you see are pretty much um, not applicable. The third one, which says without physical endpoints, it is impossible to track user activity, which is not correct. You can track it on the cloud side, right? And lack of physical endpoints increases the opportunity for physical theft and damage. Yeah, that's not true as well. Um, so it's the challenge with cloud is there is no defined perimeter as it used to be in the traditional network, and that is what um, creates the concern, and therefore you have all these controls around stressing on encryption, authentication, VPCs, which is virtual private clouds, um, and so on and so forth. So those are the controls that takes prominence to make sure that since you don't have endpoints defined, anybody from anywhere with a network access can access cloud. How do you still make sure that the risks are mitigated? Those are the things you would cover more as part of the CCSP. All right, so moving on to the next slide. When should cloud providers allow platform as a service customers shell access to the servers running their instances? Mhm. Yeah, so the answer is never. That's correct. You would never have um, a cloud provider will never allow customers to access the servers running their instances, because you would then be able to look at information of other tenants. That's the shared, I mean, which would be breach of their contract with those other tenants, right? So you'll never get that, and that's where again the aspect of SLAs, contracts come into play. Like in case you need some information from the vendor, instead of you trying to do it, it's the vendor who should be able to provide you, or the provider should be able to provide you. Let's say if it is forensics or investigations or incidents, and that should be run by the SLA or the contract terms and conditions, rather than you yourself expecting to be able to access that infrastructure, which you will not get. All right, so the next question here. Alice is the CEO of the software company. She is considering migrating the operation from the current traditional on-premise environment into the cloud. What is probably the biggest factor in her decision? Mhm. Okay, so interesting question. Let's see. The answer is the last one, reducing overall cost due to outsourcing administration. Because if you remember the first question, a software company, they're interested in making sure that they focus on building software. And for that, they would probably go for an IaaS, infrastructure as a service, um, platform as a service setup. Um, so because they don't want to worry about the rest of the underlying management and administration of infrastructure as such. Global accessibility, network scalability, offsite backup are all valid answers for anybody. But the fact that they're mentioning and stressing on a software company, you'll have to think in that way to say, um, um, what would be the biggest factor amongst these choices. So yeah, I hope that helps you understand how to interpret what the question is actually trying to get at and select the right answer. Okay, we have 3 more questions. If an organization wants to realize the most cost savings by reducing admin overhead, which service and deployment model combination should they choose? So stress on the fact most cost saving. Which one would that be? I think everybody is getting it right. Which is correct. Software as a service, which is the highest layer of abstraction. You have to worry about nothing else but just access to the portal and work. Plus, it is public. So you don't have any on-prem or I would say a private setup where you actually eventually then own the infrastructure setup as well. So this is the best combination that you would see in this question. Moving on to the next one. If an organization wants to retain the most control of their assets in the cloud, which service and deployment model combination should they choose? Very good. So remember the question, most control, like the extreme level of control they want to retain. So given the choices you have here, I would say the most control, if they didn't mention cloud, would have been on-prem setup, but they mentioned cloud. What should be the combination? So I think the answer, let me showcase, everybody got it right eventually, is IaaS and private, right? So I have the most control because it's private. Everything is in their control. Plus it's IaaS. So the bare minimum support they can get from a cloud model with everything else in their control. All right, so last question on this module is this. Your organization has migrated past a network administrator within the cloud provider has access to your data and sold a list of your users to a competitor. Who is required to make data breach notification? Okay. All right. Interesting. This one has, for a change, a lot of differing opinions. So let me lock it. Let's say the correct answer is the last, your organization. I mean, you as a customer who is ultimate accountable for the data that you own, no matter where it is processed, stored, and you as an organization are therefore required and liable to make the data breach notifications. The cloud provider is responsible to notify you, to the organization, that something happened, but they are not responsible to do the breach notifications, which are required as per the law and regulations, right? So it would be your organization who ultimately have to do the notification to the regulators, to the public, or those who are impacted. And that's why the answer is the last one, your organization. So great. Thank you for participating in this. I hope this was helpful. And I will probably do a quick time check. We may take a 15 minutes break. It's almost 3 p.m. So why don't we take a quick 15 minutes break? We come back at 3:15, and then we have about 45 minutes where we will go through the most important domain. Obviously, we won't be able to do a lot there because of the time, but we'll give you a flavor of what the data security domain is all about. And we'll do similar questions there as well. I think it will be fun to do questions. So we'll go as much as possible quickly to the questions, and then we'll wrap up for the day. So thanks for participating again so far. I will stop sharing, and we will reconvene in about 15 minutes from now. Thank you, everyone.
Anurag, will you put the time?
Yeah,
the
I
15
will.
minutes time slide, please.
Yeah. Can you see it?